Okay, so what we did last week was, let's say that we took, for example, the sine of an angle, like let's say 30 degrees. Would everybody put that after checking to make sure that your calculator is in degrees and not radians? Let's do that really quick all together. Okay, we go to mode, arrow down, arrow over to degree, and hit enter. Make sure that you're on degrees and not radians. If you don't have a calculator, get one. There's calculators floating around. Okay. So did I say sine? Okay. So if I do the sine, of 30 degrees, it should give me a ratio. Okay. And if I do math, enter on it, it gives me the ratio of 1/2. So I know that the sine of 30 degrees is 1/2. And what that tells me is that's the opposite over the hypotenuse. So if I have an angle, that's probably a little small, of 30 degrees right here, and it's in my right triangle, and I say that this little length is 1, then the hypotenuse is 2. Is that okay with everybody? That's what's happening. So if you make a little input-output table, in, out, if you take the sine of an angle, okay, you put in the angle. That's the input. Okay, that's like the x. The output is the ratio. Okay, it spits out the ratio of the opposite over the hypotenuse. So you feed it an angle, and it goes ratio, spits out a ratio. Everybody happy with that? That's what we did last week. Now today, we're going to do the function that undoes that. Okay, so the input and the output, the domain and the range are going to be flip-flopped backwards. Okay, so what's going to happen is this. We're going to feed the function a ratio, usually as a decimal, and it's going to spit out an angle. You see how it's just backwards? So let's say that I have a little triangle, and I know that the ratio is like the square. Let's say I know the ratio is 1/2. Then I can work backwards to solve that angle, x or theta. Theta is just a Greek letter like pi, and we can use it as a variable instead of x. And a lot of times we'll use the Greek letter theta for angles that we don't know. It's just a variable like x, y, or z. Yeah, that's a little theta. It's kind of like a 0 with like a little toupee, with like a little hairpiece on it. Okay, so I want everybody on their calculator to try this. You see above the sine button, there's like a little blue sine to the -1 power. Okay, that's the inverse sine button. Okay, so I have to hit the second button and then the sine button. And now if I plug in 1.5 or 1/2, you can do it either way, 0.5, it should give me my angle back. It tells me the measure of the angle that has that ratio. So it's just undoing what we were doing last week. So if I take inverse sine of 0.5, I get a 30-degree angle. So I feed it the ratio, and it gives me the angle. That's what we're doing. Okay, so we can do it for sine, we can do it for cosine, and we can do it for tangent. It just undoes the other function. Okay, perfect. So for these, all we have to do is plug these into our calculator. And what you need to know is that this is the ratio. And what you should get out is the angle. So if you're doing the inverse function, it's going to give you an angle as the output. So let's try that. Inverse cosine of 0.87. Oops, what did I just do? Inverse cosine of 0.87. I got 29.54. Nearest degree, 29.5. That's 30 degrees? Okay, 30 degrees. So we're rounding to the nearest degree. Okay, do we need to? Okay, we've already done a sine one. Let's do a tangent one, and then we'll be done with this row. Okay, let's do tangent inverse of 0.71. Inverse tangent of, was it 0.71? Yep. Thank you. 35 degrees, I'm getting. So this is the angle, and this is the ratio. What? I'm just labeling it because it's really easy when you're doing this fast to kind of forget what you're doing, and then it stops making sense. So if we can make it make sense while we're doing it, that would be ideal. I don't know that we need to do the next row. It's just plugging it in the calculator. Okay. Okay. We have to use the given measures to find the unknown angle measures or side lengths of the triangle. And that's called solving a triangle. So to solve a right triangle, we need to know two side lengths or one side length and an acute angle. So we have to find all of our unknowns here. Any ideas for how to find this side? If I already know two sides in a right triangle.
So opposite.
Yeah, we can just use the Pythagorean theorem. So I'm going to call this little r because it's opposite the big angle r. I'm going to name that side r. And it's a leg, so be careful when you set this up because it's leg squared plus leg squared equals hypotenuse squared. So it's r squared plus 5 squared equals 5.7 squared. Okay, I don't know what 5.7 squared is off the top of my head, but I can move the positive 5 squared over to the other side where it's negative 5 squared and just put that in my calculator. So I'm going to do 5.7 squared minus 5 squared do you guys remember from Algebra 1 when we wrote like the square root of 4, for example, as 4 to the 1/2 power? You guys remember doing that back in the day? You remember writing a square root as a 1/2 power? Okay. the point of that is that instead of having to rewrite the whole square root thing, you can just do power caret 0.5, which is 1/2 power, and it'll take the square root for you. You see what I did? I'm just saying, if you want to be fast on that calculator, listen to me. I'll show you how to do it. Okay, so square root, I'll show you how to do it the long way, of 7.49. And you see you get the same thing. So you can take your answer to the 1/2 power, and it's just a few less steps. A few fewer steps. Huh?
If you did just hit divide 2?
No.
You would.
No, because you're taking the square root.
Oh, yeah. Never mind. Bad idea. Right.
Okay. Okay. What does it say to round to?
The hundreds.
Hundreds? Okay, so 2.74. Okay. So my R is 2.74. Okay, now what? Which angles do we not know? We know S. S is 90. R and T. Well, we don't know that this is a 30, 60, 90 because these side lengths aren't looking like our pattern of short side, double the short side, and short side root 3. It doesn't look like that pattern from here. So we can use our trig functions, okay, our inverse trig functions. Which one do you want to solve for first? T. Okay, so for T, do you see that we have the opposite and the hypotenuse? Okay, I would suggest not using the one that you just rounded on because then you introduce a rounding error. Just saying. Okay, so which trig function uses opposite and hypotenuse? Yeah, the sine. What's up? Yeah, really quick. So we know that the sine of angle T equals 5 over 5.7. So my question for you is, how do we undo taking the sine of T? Just like we undo multiplying with dividing, just like we undo adding with subtracting, we can undo the sine. This is a function. So in order to undo the sine, we have to do the inverse sine. Oh my gosh, my brain. Okay. And if we take the inverse sine of that side, we have to take the inverse sine of this side. So I'm going to take the inverse sine of 5 over 5.7. Okay, so I'm taking the inverse sine of a ratio, and what is it going to spit out at me? An angle. Okay, so look at this. The sine and the inverse sine undo each other, and we're left with angle T.
Okay, I'm sorry. What is the sine minus 1 again?
Inverse sine. It undoes the sine. It's like the inverse operation of sine. Okay. So we're left with angle T. So we just have to put it in our calculator. So we go to the calculator. We do the inverse sine of 5 divided by 5.7. I forgot to put a parentheses on that. Let me fix that. I know, but there's a division symbol in there. I feel better if I close the parentheses because we're dividing. Yeah, okay. Sometimes it makes a difference. So what does it say to round to? Yeah, 61.31. Okay, so the measure of angle T is 61.31 degrees.
So 90 point.
Now we can either subtract the 90 and the 61.31 from 180 to find the last one, or we can say, okay, well, for angle R, this would be the adjacent and the hypotenuse. I'm just saying that you could do it either way. Do you want to practice it with the cosine, or do you just want to subtract them from 180?
Just subtract.
Okay, so what is 180 minus, whoops, that was 18. 180 minus 90 minus 61.31.
I think it's like 28.69.
That sounds right. 28.69. Okay, so those were our three unknowns. We found the R, we found the measure of angle T, and we found the measure of angle R. R was ST, right?
Yeah.
Okay, questions? Let's try another one. All right, we're going to the nearest hundredth again. Okay, this time we have an angle and a leg. So what piece of information would you like to find first? How do we find our last angle, for example? How do we find the measure of angle D? Yeah. So the measure of angle D will be 180 minus 90 minus 58, which is
32.
okay, 32 degrees. Thank you. Let me just rewrite that. Measure of angle D equals 32 degrees. Okay, that one was easy. That was one piece of information. Now I have to find my other leg and my hypotenuse. So let's do, which one do you want to do first, leg or hypotenuse?
Hypotenuse.
Okay, let's do the hypotenuse. So we start from the angle that we're given is a really good habit because then we don't have any rounding errors. And then if you made a mistake on here, doing this one for whatever reason, then you don't introduce that mistake into the rest of your problem. So if you start with what you're given, you're better off. So from our 58-degree angle, the 14 is the opposite side, and the hypotenuse is, of course, the hypotenuse. Let's call that E, little e.
Opposite over hypotenuse, that's it.
Yeah, opposite over hypotenuse is the sine. So the sine of 58 degrees equals 14 over E. Do we have to use the inverse sign for this one? No, because we're not trying to find an angle. Okay, we already know that we're doing the sine of 58.
And we do.
What we need to remember is that we want to get that variable up in the numerator so that we can solve for it. Remember that there's a 1 under the sine of 58, so we can cross multiply. So we have sine of 58 degrees times E equals 14. And then we can divide both sides by the sine of 58. So E is our DE.
Ms. Wyman, can I have Haley Huey come to the office with her stuff? She's leaving.
Yes.
Thank you.
Okay, so 14 divided by sine of 58. 14 divided by sine of 58. I got 16.51. 16.51 units. Okay, let's look at, we'll call this side little d. With respect to our 58-degree angle, little d is the adjacent. Good. And then the hypotenuse is still the hypotenuse. And now we know what the oh, we have the opposite.
Yeah.
Okay, we still have the opposite. And then we have the adjacent. So which of our trig functions uses opposite and adjacent? The tangent, good. So tangent of 58 degrees equals our opposite, which is 14, over our adjacent, which is d, little d. Okay, it is time for me to show you one of the most useful algebraic tricks you will ever find in your life. Okay, do you see where the sine of 58 and the e started out right here? Okay, once these cancel, look at where they ended up. Do you see that they're still on the same diagonal? They just switched flip-flop spots? That happens every single time. So anytime you're cross-multiplying like that, where you can have cross-multiplying, you can just switch these two. You can just switch their spots. If it feels better to cross-multiply still, then by all means, but it will make you a lot faster if you can just say, oh, it'll be d equals 14 divided by tangent of 58 degrees. Do you see what I just did? I just switched their spots because that's what happens every time we cross multiply. Everybody happy with that? Okay.
Class, that's a good trick you need to do. I call it flip and switch. We do that technically. Flip and switch.
Mm-hmm. But the reason it works is because of cross multiplying and then dividing both sides by the same number. Like it's mathematically based. So for a few days we did it the long way. Now I'm showing you the shortcut. So, all right, so let's find out what 14 divided by tangent of 58 is. 14 divided by tangent of 58. I got 8.75. D equals, that's EF. What did I say? 8.75?
Yeah.
Yeah, thank you. 8.75 units. Okay, double check that your hypotenuse, DF, is the longest side and that your answers kind of make sense. Okay, is your longest side across from your biggest angle? Is your smallest side across from your smallest angle? Okay, that's a good way to check your work without having to go back and like crank out the whole thing. Any questions about this? All right, let's try another one. Okay, a highway sign warns that a section of road ahead has a 7% grade. To the nearest degree, what angle does the road make with a horizontal line? Okay, so this is the horizontal line. So they're asking for this angle. Okay, we can call that angle theta.
Theta?
Okay, so with respect to angle theta, what is the 7 feet? I'm looking for opposite or adjacent? Opposite. And what is the 100 feet? It is the adjacent. Okay, so which of our trig functions uses the opposite and adjacent? So we're asking about SOHCAHTOA. If we're using opposite and adjacent, we're using tangent, right? Okay. So I'm going to say that the tangent of my angle theta equals the opposite 7 divided by the adjacent 100. I did not give myself enough room. I'm going to write it farther over here. Sorry. Now, I'm trying to find an angle. The angle is my unknown. I have a ratio. I want an angle. So I'm going to undo the tangent function, right, and get an angle. So I'm going to undo the tangent using the inverse tangent. And if I do the inverse tangent of this side, I must do the inverse tangent of that side. It's the function that undoes the tangent. If I feed it a ratio, it gives me an angle. So the tangent and the inverse tangent undo each other, and I'm just left with my angle theta that I was solving for. On my calculator, I can do inverse tangent of 7 divided by 100. Whoops, they're not 110. Your calculator doesn't care whether you give it the ratio as a decimal or a fraction. It's not particular. I got 4, what does it say to round to? Nearest degree. Does it say nearest degree?
Yeah,
Full degree? Okay, so we're going to say 4 degrees. So theta equals 4 degrees. So I guess we can call that the measure of angle A. We can also write a sentence. That might be worth a point on the test. So the road makes a 4-degree angle with the horizontal. I would say when you're solving a triangle, I don't need a sentence from you, but for a word problem, just like in Algebra 1, you probably need a sentence. Probably, definitely. All right, let's look at this one. Baldwin Street in Dunedin, New Zealand is the steepest street in the world. It has a grade of 38%. To the nearest degree, what angle does Baldwin Street make with the horizontal line? Okay, so here's our horizontal line. Okay, this is our angle. What do you want to call it? X, theta, X? Okay, so with respect to our angle X, what information do we have? That's an opposite. And then this is the adjacent. Good. So if we're thinking about SOHCAHTOA, and we have opposite and adjacent, we're going to need tangent. So then we just start filling in what we know. The tangent of the angle X equals opposite 38 over 100, which is the adjacent. Oh, I'm going to give myself a little room. How do we undo the tangent? Inverse tangent. So if I do inverse tangent of this side to undo the tangent, I have to do it over here as well. So that gives me X equals the inverse tangent of 38 over 100. So I can do inverse tangent of 38 divided by 100. Yeah. What does it say to round to? Nearest degree. So 21 degrees. 21 degrees. So Baldwin, not Vlad, Baldwin. Baldwin Street makes a 21-degree angle with the horizontal. That's steep. How'd you like to bike up that bicycle? Is that the end?
Yep.
We're done.